All right. So in addition to being MC, I am also, well, I'm still Drew, but I am the PM for the Platform Predictability program.
And I'm Rick Byers, the TL.
So if you guys haven't met us, feel free to come up and say hi in the breaks. Not right now, that would be kind of distracting. But in general, I wanted to take some time, and with Rick here as well, to talk a little bit about predictability, which we talked about at last BlinkOn as well, actually. And we sort of came at it from this perspective of we want the web just to work for developers. We want to make it so that it's a predictable platform. It's something that you can sort of develop for confidently, and that it's not incurring a lot of extra unnecessary cost. But we all know this is like a really good goal, and this is sort of the altruistic portion of predictability. But I wanted to take a step back, probably surprising no one as a PM, and talk about the strategy behind predictability and why this is kind of a really cool moment where our incentives, as Chromium, as a web browser, and our sort of moral leanings come together. And I think it's really cool. So if you think about the web platform, it's actually not one entity, right? It's a few rendering engines. We've got Gecko, Chromium, Blink, we've got WebKit, we've got the Edge rendering engine. All of these, you can think about them being held together by an elastic band. So if you've talked to Alex Komorowski ever, you've probably heard this ad nauseum. So sorry for the repeat. But if you imagine these 4 rendering engines held together by an elastic band, and that elastic band is the web platform that developers know and love and hate and work with. The fact that it's elastic is really important, because if the 4 browsers, or the 4 rendering engines were forced together and forced to move in lockstep, right? There was no sort of elastic stretch, then the web would never really move forward, because you'd need agreement between all 4 engines before you could make progress in a new area. So what the elastic allows us to do is to stretch the platform in different directions, to try new things. It's kind of genetic diversity, right? We can go where we think the most important things are. And that creates natural tension in the elastic. This is also really good because that tension is self-correcting. If a browser moves in a really good direction, or if a rendering engine moves in a really good direction, and they get lots of buy-in from web developers, that tension will slowly pull the other engines in the same direction, and will sort of relax the stretch, will achieve interoperability. But also, if an engine does something that turns out not to be a good idea, I mean, this is common in anything new, the tension will pull them back. They'll deprecate, they'll remove, and will again move back towards interoperability. So this is really, really powerful, because it allows us to experiment while continuing to keep the reach and the scope and the diversity of having multiple implementations of the same web platform. But elastic can break, and this is what failure looks like. If any engine, any browser gets too far ahead, too far different from the other browsers, then the sort of elastic web breaks down, and now developers can no longer target the web platform as a whole. They have to build for each individual browser. So we've sort of failed in this case. So you can think of the elastic stretch that's remaining in the web platform as our budget for pushing the web forward. The more tense, the more stretched that elastic is, the more time we have to spend working on interoperability, fixing bugs, the less time we can spend driving the web forward. That's also a way of thinking of it. The more stretch we have, the more we can say yes to everyone's cool features. All right. Why would the platform break? Well, I gave one example, and that is when one engine gets too far ahead. Now, this is if someone focuses too much on features, if they focus too much on sort of going out without consensus, they work on things that other browsers, other engines can't or don't want to implement. This one I think everyone probably can think about intuitively. Another one, for anyone who hasn't seen Game of Thrones, recommend. Another one, though, is kind of the inverse of this. If any one browser with, or any one rendering engine that has a lot of users ends up kind of taking too long to get to the party, right? That's the same thing, but it's different. It's not just that one engine is going slowly. or not working on things, there is a real second mover disadvantage that can come. If one engine creates a new feature and they don't invest in interop testing, if they just put it out there and developers adopt it and there's weird quirks, unspecified behavior, then the next implementer has to come along and reason about what that behavior is. They have to write interop testing suites to make sure they work with the existing implementation. They have to convince web developers to change if they've adopted some of the weird behavior. And then there's also the problem that as a newcomer, like someone like Edge, for example, who had to sort of rebuild their engine from scratch, they had to invest a lot in copying Chrome's behavior to make sure that they would work with the websites that actually exist today. So this means that if you're not responsible pushing forward, you can leave a lot of landmines and debt for other browser implementations, which makes it harder for them to remove the elastic stretch, even when they want to, even when they're trying to. And finally, if the web is not a productive place to develop, then developers don't have the time to fix small issues here and there, right? If the platform is changing out from under you, if regressions are causing you every 6 weeks to scramble and fix your site, you don't have time to invest in new features that you feature detected on one browser but not the others, right? So the more productive we make developers, the more inherent stretch exists in the platform for us to utilize. So ultimately, this is the strategic goal of predictability. We want focused tension, meaning that we only invest in stretching the elastic when it makes sense, when we think it's really important for the web to move forward in this location or in this area. We want faster second, third, fourth, fifth implementations. We want to make sure that when you ship something, you're paving the path for everyone to follow you as quickly as possible once it becomes clear that it's a good idea. And we want more productive developers. We want developers to be able to maintain or sort of exist with that stretch and still be successful so that the platform can continue pushing forward in areas that we think are important. So that's a high-level view of why this is not just, being a good citizen, not just doing good for developers. It's also critical to Chrome's mission. Now, as is a good PM tactic, I'm going to hand it off to Rick for the actual details and let him talk about all of the amazing work we've been doing.
Thanks, Drew. That was great. So 6 months ago, if you were at BlinkOn or if you watched the talks, Philip and I introduced this notion of platform predictability. So really, I just want to go through. We promised that we were going to build a bunch of infrastructure and a bunch of tooling to help us as a whole team invest in this space. So I'm just going to go back through some of those promises we made and see where we did, which ones we've delivered on, and also give you an idea of what are the specific things we're investing in going forward. So first and foremost, we said that interop testing was huge, and a ton has happened here. This has really been our top priority. In fact, just yesterday, we had a meeting here at Google with 20 engineers from Apple, Microsoft, Mozilla, Google, and elsewhere who are all super excited about this space. There's been lots of progress. Most importantly, we believe that Chromium's now at the point that it's basically as easy to write a web platform test along with your CL as it was to write a layout test. There's some bumps, there's some cases that don't work well, but we're now ready to start dog fooding where you can just edit web platform tests along with your CL, get a normal code review in the normal way, and they'll get automatically pushed to GitHub without you having to do any additional work. So we've got this auto two-way sync working now. There's some cost with this, but there's also this benefit that sometimes when you start to work on a feature, you're not going to have to write your tests at all because one of the other vendors or somebody else has already written them for you. So we believe that that's about equals out, and there's a net win for people now to use web platform tests instead of layout tests when you want to do end-to-end integration testing of your feature. There's lots more to talk about here, but I'm not going to talk about it now. Philip's giving a talk tomorrow at 1:45. Please watch the recording or attend in person. We also promised that we're going to do a bunch of things to make it easier to invest in interop. We've been playing with a few different tools. Luna sent an email to Blink Dev a few weeks ago talking about this IDLE spec conformance tool. We have this notion that hopefully eventually when you edit an IDLE file, you'll get a pre-submit warning warning you about any places where your IDLE file doesn't match the specs. We've done some manual runs and identified a whole bunch of differences. and in particular, just with 1 week hacking together with Philip in Stockholm, they fixed 19 little spec conformance issues and filed 10 spec bugs, because the tricky part here is always deciding, do we change Blink, do we change the specs? And so we're working on scaling up that tool to something that's useful for all of you, and talking with the other browser vendors as well, hopefully making that useful for other browser vendors. We're also starting to invest in tooling for what we're calling API confluence. And really, you can think of this as trying to visualize the elastic band, trying to say, how are APIs moving with different engines, answering questions like, of the features we shipped in Blink 2 years ago, how many are now in at least 1 or 2 other browsers? If they're not in other browsers, like, let's go back and look at that and ask ourselves, why? Did we make a mistake there? Were we wrong? But the most important thing in this space, in improving interop, obviously, is all the work that you do, right? Every patch that you write, all the effort you put into code reviews, writing specs, filing issues on specs, filing issues on other browser vendors. That's where really all of the improvements in interop are coming. And we've seen everyone seems to care about that a lot. We've seen lots of investment there. For example, in the past 6 months, there's been 415 bugs that are tagged as being important for interop that have been fixed. So please keep that up, and thank you. That's the most important part of all this. We also promised we're going to invest in some tools to help us reason more about web compat. In particular, there was a lot of problems with our use counters. We've now got a new set of use counters landed under these new histograms, blink.usecounter. It's in M57, so we're not going to update the Chromium status dashboard and really start using them until M57 is stable. So look for that at some point. Probably switch the dashboard over in Q2 once we've got a bit of history. Overall, we're seeing that once a number of the bugs were fixed with use counters, the actual absolute values are about 3 to 6 times higher than they were before. So when you thought you were only breaking 0.03% of pages, you were actually breaking 0.1% or maybe 0.2%. So some of that might be cause for concern. There's a couple outliers. I just posted some raw data on this to the platform predictability list if anyone's interested. It's now easier than ever to try to identify specific sites that are hitting your use counters. The HTTP archive data now has use counter data in it, so you can write a simple BigQuery query that says, of the top 500,000 websites, which ones hit my use counter on page load. So hopefully that makes it easier to try to understand, hey, I'm seeing a larger number in my use counter than I thought. Why? And it's rare to need to do this, but sometimes you really want to do a more sophisticated analysis. And so we've now, working with the Skia team, we can do use counter analysis using the cluster telemetry crawling framework. So we can crawl. I did this when working on the event listener options API. We wanted to ask some questions and get a quick answer. So for example, how many sites or what sites in particular are calling at event listener with this particular strange pattern that we're going to change the behavior of. So you can write a patch, run it on a crawl on the top 100,000 sites, and within a few hours get back answers of which of those sites hit that patch. And this was really useful. For example, Servo folks reached out to me and said they want to prioritize what DOM APIs they should work on. And so they wanted data on what websites are using what DOM APIs. So they gave me a Chromium patch that added like 2,000 or 3,000 more use counters that we were never going to land. And we ran that on the cluster, and we're able to say, okay, of these 3,000 DOM APIs, here's the ones that are on the most sites and which sites and that sort of thing. So this can occasionally be useful. All of this is now documented. There's a compat dueling guidance page off the predictability project page with details on these and other tools. Reducing compat pain and improving interop, it's obviously important, but it really relies on engineering discipline, right? We can't know what problems are worth fixing if we're not paying attention to our bugs. So we've also invested a bunch in bug tooling. We've improved the new bug wizard so that more and more now when developers file bugs, they come directly to your team. They get the right labels on them from the start. They get regressions, get an automatic bisect that points to the CL that triggered the regression. So hopefully regressions can be acted on much quicker now. And as Emil and Josh mentioned, we had great momentum, although it's kind of flattened out recently. And let's see, in particular, if you break down the open and close rate by label, you see we're pretty consistent. The labels that have the most incoming bugs also have the most closed bugs. This is over the past 6 months. There's some teams that are really kicking butt, like Layout, which is fixing way more bugs than they open. Thank you, Emil. But there's work to be done here as well. And Drew will talk about this a bit more. We also talked about the need to give developers tools to help reduce foot guns. One of the big areas we're investing here is an API called Feature Policy. And Feature Policy is an API that lets developers enable and disable features for their document, and in some cases for any iframes they include. And this is really exciting for two reasons. It helps developers reason better about a large, complicated application. You know, imagine you're Facebook or something. You've got thousands of developers. You want to just say, no, look, Facebook's not allowed to use SyncXHR. Don't let it. You know, have some way of failing. But it also gives us a tool to better balance ecosystem alignment with predictability, where we can start to instead of saying, oh, we're just going to break something universally, maybe we can use an API to explicitly opt in or opt out of different default policies for cross-origin iframes, for example, and give developers an easy way to flip back if that's not the policy they wanted in their case. So this is work in progress. There's stuff landed behind a flag that you can experiment with today, specifically vibration, full screen, and SyncXHR are controlled by Feature Policy. The hope is to ship this in Q1. There's also been a lot of work, obviously continued work to remove non-standard APIs, 30 in the last 6 months. And some that we thought were intractable are looking less intractable. So for example, file system, we've long thought file system is a Chrome-only API. The usage is pretty high. I think it's 0.4%, according to the old counters. I forgot to check the new counter, but which is probably too high to break. But when we started digging into that usage, we realized most of it was actually malicious. So most of that 0.4% is actually stuff we want to break because they're abusing file system to do nasty things for the user. So I'm excited about that one. And we're starting to work on the notions of CSP reporting, where CSP can report errors back to servers. That's been super useful in getting people to adopt CSP, which is a content security policy. You know, you want to enforce some new rules for security on your site. We've realized that's really a general pattern, and what we're talking about here, things like interventions and deprecations, are really just another instance of that pattern. So that's generalized now out of CSP into a new spec called the Reporting API, and we're working with Patrick from Edge to define how we're going to use that API to give developers APIs to see when they're relying on an API that's going to be deprecated or they're triggering interventions in the wild. And of course, in terms of developer guidance, the biggest project across Chrome, hopefully everybody's heard of Lighthouse at this point. Lighthouse has all sorts of advice on performance and how to build a great PWA, but it also has a bunch of stuff on best practices. And so for all of this guidance, we're working on a generic unified framework so that console warnings, Lighthouse warnings, and reporting API reports are all based on the same set of guidance that Chromium and Blink want to provide to developers. There's also been a bunch of investment in getting more feedback from web developers. We've worked with DevRel to launch a new web feedback page, which includes this cool little browser bug searcher. If you haven't seen it, it's one nice little form where you can search all the WebKit, Chromium, Gecko, and Edge bug databases at once. It's very cool. And we've done a survey now, an initial survey of web developers to better understand their pain points. We're working with UX research on that, and we're starting to analyze that data. All right.
Okay. So real quick, do a lightning round of our 2017 goals. Then I know we're standing between you guys and break, so it'll be quick. These are sort of the numbers you can hold us to. At BlinkOn 9, hopefully we will have an update where we say, yep, we hit all these numbers. So the first one is around interoperability. And again, I'm just going to sort of fly through this really quickly. But we want to increase our web platform test rate significantly. I think this would be about a 5% increase in our pass rate, 5 or 6%. We also want to make sure we're not just committing to Chrome's improvements, but also that the number of web platform tests passing everywhere is up 5%. So this means we want to make sure we're investing in ways that allow other browsers to be using web platform tests to make the results meaningful and so that they can continue leveraging them as well. There's a few other things here, right? We want to figure out a way to make sure that the features we're shipping are shipping in other browsers and other engines. So we're going to have some metric put together, hopefully within this year, on the number of things that haven't shipped in 2 or more engines within 2 years from shipping, and trying to understand why. We're also hoping that all 2016 PWA features, so features that are key to PWAs, have shipped in at least one other engine by the end of 2016. 2017. Still kind of new year. Okay, the last one, and then I'll just I'll let you guys go. We really want to make sure we're continuing to beat the drum about bug health. This is something we've made enormous strides in, but we've heard a couple times now that we're sort of slacking off a little bit here. We're flattening out. So the biggest one that we really don't want to regress on is that all Blink bugs should be triaged within 1 week. And this is just triage. This doesn't mean fixing bugs. It just means looking at each bug and making sure you've made a conscious priority decision about them. For that, we're going to expect that all teams in Q2 and onward have an OKR around maintaining the 1 week bug triage SLA. So if you have concerns about that, feel free to come talk to us, but that's something we're really going to double down on. After that, we want to make sure that any prize 0 or 1, prize 0, prize 1 regressions are resolved within 30 days of bug filing. Now again, key to this is it's resolved. So if it was an intentional regression or something like that, you can just close the bug as won't fix, and that still counts. And it's only prize 0, prize 1 regressions. We also are experimenting with something this year, which is trying to really pay attention to and look at stars as an important signal. So we're hoping that 90% of Blink bugs with more than 32 stars will be fixed by the end of this year. So you might be wondering why 32 stars? That represents the top 1% of bugs ever filed on Blink. So there's not many of these, and this target might move if we manage to fix a lot of these, but this is sort of fix the top 1% of bugs in terms of developer pain, or as close to that, as close to 100% as we can get. And there's a lot of progress in this, actually. We're shipping things like APNG. There's a local storage bug we're looking into potentially fixing. All these have like 900 to 1,000 stars, so we're making a lot of progress here. All right, I will skip over this part because this is largely around shipping Lighthouse, which I think we all really care about. So in the end, we just want the web to work for developers. This is strategically and sort of morally important to us, and something we really want to invest in. But at the end of the day, it all depends on you. As you heard in the keynote, programs we're like the bazaar, right? We're trying to convince you guys this is important, but we need you guys to really invest in the work to help us find what's important and to sort of be the boots on the ground getting a lot of this done. So we can't do it without you. And if you have any questions, you want to get more involved, come find us in the break. Yeah, thank you.
Thanks.
So